Welcome. Let's take a look at finding the limit of continuous functions. The example we have first here is let f of x equal x cubed plus 4. And what we want to do is find the limit as x approaches -1 of f of x. Now down on the left, we have the reminder that the following functions are continuous on their domains: polynomials, rational functions, trigonometric functions, root functions, exponential functions, logarithmic functions. All of those functions are continuous on their domains. And so when I look at this function f of x, I see x cubed plus 4. So that's a polynomial function, and it's continuous on its domain. And the domain of a polynomial function is all real numbers. So this function is continuous everywhere. And we also know that if a function is continuous at a, then the limit as x approaches a of that function equals f of a. So what we want to do here is find the limit of this function f of x as x approaches -1. So the limit as x approaches -1 of x cubed plus 4 is equal to what the value I get when I substitute in -1. So that's going to be equal to -1 cubed plus 4, or -1 plus 4, which is equal to 3. Now, we have the graph of this function down here on the lower right, and here is -1. And we can see based on the graph that as x gets closer and closer to -1, let's say perhaps on the left here, that the y values are getting closer and closer to 3. And as x approaches -1 from the right-hand side, we can see that those y values are in fact getting closer and closer to 3. So the limit of this function as x approaches -1 is equal to 3. Here's the second example. We've got g of x equal to 2 cosine of x, and we want to find the limit as x approaches pi of g of x. Now, recall again that there are a number of functions that are continuous on their domain, and among those is trigonometric functions. So g of x is cosine, and cosine is continuous for all real numbers. So g of x is continuous for all real numbers. Therefore, we can take the limit as x approaches any real number, and in this case, we're interested in pi. So we're interested in what is the limit as x approaches pi of 2 cosine of x. Well, because that function is continuous at pi, we can simply substitute pi in for x. So we get 2 times cosine of pi. And cosine of pi is -1. So this limit is equal to -2. And we can see that in the graph we have here on the lower right, because here is pi on the x-axis, and we're interested in what happens as x gets closer and closer to pi. So as we move along this curve, letting our x values get closer and closer to pi, notice that the output, or the y values, are getting closer and closer to -2. Similarly, if we let x approach pi from the right-hand side, and so we can watch our y values as x gets closer and closer to pi, and we can see that they are in fact approaching -2. So we can verify that with our graph here. Here's our next example. We're looking at f of x equal to x plus the square root of the quantity x squared plus 3. And we want to find the limit as x approaches 1. So notice again, we're talking about a root function, which is continuous on its domain. And if we look at the value we're interested in with respect to x, we simply need to ask ourselves, is x equal to 1 in the domain of our function? Well, certainly we can replace this leading x with 1. There are no issues with substituting 1 here. And then we need to check if 1 is in the domain of this radical function. And it is. If I square 1 and then add 3, I get a positive number, which I can take the square root of. So this function is continuous at -1. So let's go ahead and find the value of this limit. Now, because we know that our function is continuous at x equals 1, the limit as x approaches 1 of x plus the square root of x squared plus 3, that's going to be my function evaluated at 1. So I'm simply going to substitute in 1 for x. So we'll have 1 plus the square root of 1 squared plus 3. So that's 1 plus the square root of 4, which is 1 plus 2, which is 3. So the value of that limit is 3. Now we can come over here to our graph and verify that. Here is 1 on the x-axis. And as we let our x values get closer and closer to 1 on the left-hand side of 1, we can see that our y values are increasing and approaching 3. Similarly, if we allow our x values to get closer and closer to 1 from the right-hand side, we can see that those outputs, those y values, are decreasing and getting closer and closer to 3. So indeed, the limit of this function as x approaches 1 is 3. Now we're going to take a look at one last example that incorporates a slightly different take on finding a limit with continuous functions. Notice that we're going to assume that f and g are continuous. So the limit as x approaches 2 that we have here stated is perfectly legitimate and can be considered. Okay, so what do we know? We know that g of 2 is equal to -4, and we know that the limit of f of x squared minus 2g of x is equal to 8. Now notice we know the value of the limit. We're not trying to find the limit. We know that the limit is 8. What we're trying to find is the value of f, of the function f, when x is equal to 2. When f of x is equal to 2. We have sufficient information here, and we're going to apply the limit laws and work our way through this. So we're going to start by simply copying our limit. So we've got the limit as x approaches 2 of f of x squared minus 2g of x, and we know that that equals 8. So we've got a difference here. We've got this subtraction, so we're going to apply the difference rule. So we have the limit as x approaches 2 of f of x squared minus the limit as x approaches 2 of 2 times g of x. And we know that that is equal to 8. again, continuing with our limit laws, we have the limit as x approaches 2 of f of x squared. So in taking the limit of f of x, instead of taking the limit of f squared, now we're going to take the limit of f and square that quantity. Minus 2 times the limit as x approaches 2 of g of x, and that should all equal 8. So at this point, the fact that both f and g are continuous is helpful, because if f and g are continuous, then we can simply evaluate those functions at 2. So this would become f of 2 squared minus 2 times the limit as x approaches 2 of g. G is continuous, so that is equal to g of 2 equals 8. Now recall, we were told that g of 2 equals -4. So we're going to have f of 2 squared minus 2 times -4 equals 8. So we get f of 2 squared minus 2 times -4 is going to be a plus 8 equals 8. Subtracting 8 from both sides of the equation, we get f of 2 squared equals 0. And then applying the square root property to both sides of the equation, we get f of 2. Now, in general, equals, we'd want to do plus or minus the square root of the right-hand side. But in this particular case, the right-hand side is 0, so the plus or minus does not come into play. So this is actually equal to 0. So what we know now is that f of 2 has to be 0. I hope you find this helpful.